Rational exponent and radical expressions. Objectives. Illustrate expressions with rational exponents. Simplifies expressions with rational exponents. Write expressions with rational exponents as radicals and vice versa. Examples of rational exponential form. 25th raised to 1 half times 2 x to the 4/5, xy to the 3/4. And let's review adding fractions and subtracting fractions. So let's add 1/5 and 2/5. Just copy their common denominator, that is 5, then add 1 and 2, we get 3. 4/5 plus 2/5, it is also in similar fraction, so add 4 and 2, we get 6. Then copy their common denominator, that is 5. And we get 6/5. Another 1/5 plus 1/5 and 1/5, we get 3/5. So let's subtract this. So in subtraction, we have the same rule with the addition. Just copy their common denominator, that is 5. Then subtract 4 and 2, we get 2. What if we have here dissimilar fractions such as 1/5 and 2/3? Our denominator here is 5 and the other one is 3. So what are you going to do first? First thing that you have to find is the LCD. How you're going to find the LCD? Just get their common factor. Since 5 and 3 doesn't have a common factor, so you can find or by multiplying these two numbers, 5 and 3. So we get 15. So to get the new numerator using the denominator 15, our LCD, just divide the LCD into the original denominator, that is 5. 15 divide 5, then multiply to 1. And the 1 here is the numerator. On the other side, just divide the denominator into the old denominator, then numerator. Then we get here 3. 15 divided 5, that is 3 times 1. 15 divided 3, we get 2 or 5. Then multiply into 2. Then multiply this one, we get 3. 5 times 2, the answer is 10. Then add 3 and 10, we get 13. Then copy their common denominator, that is 5. Our final answer here is 13/15. In multiplying fractions, you have to multiply numerator to numerator and denominator to denominator, then simplify your answer. So we have here 3 times 2, 6. 5 times 7, we get 35. And since 6 doesn't have a common factor, so 6/35 is already our final answer. In dividing fractions, you have to get the reciprocal of the divisor. Then, the dividend is remain. 4/5 divided by 2/5. So, get the reciprocal of 2/5. Or you just can interchange the numerator and the denominator into this. So, instead of 2/5, we write 5/2 and proceed to multiplication. So, we get 5 or 4 times 5, the answer is 20. 5 times 2, the answer is 10. Or you can simply divide 20 divided by 10 because the 20 is divisible by 10. Or we get 2. Now, let's apply those concepts of fraction in simplifying the rational expressions or rational exponential form. So let's multiply a raised to 1/2 times a raised to 3/2. So applying the product of powers, you're going to add the exponent and then copy their common variable, that is a. Just add 1/2 and 3/2. Since this is the similar fraction, just copy their common denominator, that is 2. Then 1 plus 3, we get 4. Then simplify 4/2. 4 divided by 2, is 2. Therefore, our final answer here is a raised to 2 or a square. Next, so applying here the power of a power or multiplying the exponent of the inside term to the outside exponent. So let's apply the rule of multiplying fractions. So 6 times 1, we get 6. Then 6 third, then copy 6x here. 6 third, 6 divided by 3, the answer is 2. Then we have here 2, then distribute 2 into 6 and x. We write 6 square times x square. 6 square is equivalent to 36, then copy x square. Therefore, this is our final answer. Remember, 6 square doesn't mean 6 times 2. 6 square means 6 times 6. That is equivalent to 36. 9/4 raised to 1/2. First, observe our given here. Since 4 and 9 are both perfect numbers and they came from a number multiplying by itself, and these are the two numbers. That is 2 times 2 and 3 times 3. And don't forget to distribute the exponent by applying the power of a quotient. So after we distribute the power here into our quotient, then expand 4 and 9. Then write down the exponential form of the 2 times 2 and 3 times 3. The exponential form of 2 times 2 is 2 square. 3 times 3, that is 3 square. Then, copy their exponent, which is 1/2. Then, applying the power of a power, 2 times 1/2, that is 2 halves. 2 times 1/2, that is 2 halves. Then, copy 2 and 3. Then, we can cancel the 2 and 2 because 2 divided 2 is imaginary 1. 2 divided 2 is imaginary 1, so the final answer here is 2/3. Another, simplify this one. 12 raised to 2/3 times 12 raised to 1/2. So apply the addition of fraction here. As you can notice, the denominator are the same. Therefore, this is the similar fraction and you have to find the LCD. The LCD of 2 and 3 is 6. Alright, 6 divided by 3, that is 2. Times 2, we get 4. Next, 6 divided by 2, the answer is 3. Times 1, we get 3. Next, add 4 plus 3, 7. And then copy the denominator, which is 6. Then let's factor out the 7 here from 1, 6. 6 plus 1, that is 7, times 1, 7, 6. Okay, to simplify the exponent of this one because the numerator is greater than the denominator. Alright, next. Then multiply 1, 6 here. As you can notice, the 6 and 6 here can be cancelled out. So we get 12. Then 12 raised to 1, 6. That is 12 raised to 1, 6. Now, this is the final answer. Now, remember, in exponential expressions with rational exponents can be expressed into radical expressions. And radicals, an exponential number whose exponent is a rational number can be expressed as radicals. So, from the rational exponential form, a raised to m over n to nth root of a raised to m, you have to write the base here as the radicand. Then, the denominator as the index. The numerator as the exponent of the radicand. So, here are their names. So, from numerator, so it became exponent of the radicand. From denominator, it became the index. Then, our base is now the radicand. Now, radicals We are going to write rational exponents into radicals. Radical expression or radical is in the symbol of nth root of a is called radical. As you can see, the symbol, this is similar to divide, but there is a pointed part here. And there is an index. This is called radical. Another, it is an expression containing the symbol, this one, this is called radical sign. Nth root of a. So the n here is the index or the order. The order, which indicates the degree of the radical, such as the square root. So it can be cube root, fourth root, and if you don't see any number here, just blank, or nothing is written in this part, that is called square root because the 2 here is already imaginary. Nth root of a raised to m. The a here is the radicand because a or any variable written inside the radical symbol, that is radicand, is a number or expression inside the radical symbol. It can be variable or any number. That is called radicand. Now, m here is the power or exponent of radicand. As you can see, this is radicand and it is its exponent or power. Now here, 3 is the index and x is the radicand. By the way, 4 here is written in smaller form. And 4 is the exponent of the radicand. Now, let's try the following. How to write this into radical form. So, I have here two examples. So, I will give you time to think of your answer. So, I have here 5 items. First, I will show you my first example. 3 raised to 2/3. If you're going to write that into radical form, 3 is the index because 3 is the denominator. Then copy the 3 here as the base. Then 2, our numerator, is the exponent of our radicand. Then after that, expand. Because this is 3 square, 3 times 3, that is 9. And our final answer here is cube root of 9. Another, 2n raised to 3/5. Alright, the 5 here is the index. Then the 2n is the radicand. And 3 is the exponent of the radicand. And after that, distribute. Distribute the exponent, which is 3. So we have here 2 cube and then n cube. 2 cube is equivalent to 8. Why? Because this is 2 times 2 times 2. So we get 8. So our final answer here is 5th root of 8n cube. Now it's your turn. I want you to apply your ideas on how to rewrite this rational exponential form into radical form. So another given. So I will give you time to write or solve using a scratch paper. Then let's see if we have the same answer. Alright, I think you're already done. Now let's check if we have the same answer. So first, 5 raised to 3/4. So 4 is the index, 3 is the exponent of the radicand, and 5 is the base. So expand 5 cube. 5 cube is 125 or 4th root of 125. Do we have the same answer here? Alright, very good. Next, 3 times b to the 3/2. Since the 3 here is not included to the exponent of 3/2, so you're just going to put only b inside a radical symbol. And 3a's remain outside our symbol. And then the 2 here is imaginary because it is called square root. Alright? So the 2 is imaginary and 3 is the exponent of the radicand. Next, simplify. And already this is, our answer here is already in simplified form. Number 3. 3 over 2p square raised to 2/3. So, all of them are all included into the radical symbol. So, 3 is the index here. And then, we have here the exponent 2 each. You're going to distribute the 2 into 3, 2, and p square. Okay, just distribute the exponent. Okay, just multiply 3 twice because the exponent is 2. 3 times 3, the answer is 9. 2 square is 4 because 2 times 2, the answer is 4. And applying power of a power here, 2 times 2, we get 4. Alright? Another. So this one shows a negative exponent. When we say negative, you're going to get the reciprocal of this quantity. Since this is in the denominator, okay, you are going to put that in the numerator to make it positive exponent. But before that, since they are both the same denominator, therefore their index is the same. Then write down the radicand inside our symbol. Then don't forget to write down the negative here. Then write the exponent as positive or imaginary one. Then get the reciprocal of x squared minus 3. So it will be written above or in the location of the numerator. So our final answer is cube root of x squared plus 3 times the quantity of x squared minus 3. Sorry. So I forgot to this part. I have to divide p to the fourth power into cube here. So we have here p. And then the remainder is imaginary 1. And don't forget to write 1 above because p is below and this is in fraction form. Next, let's move on. X plus 5 raised to 1/4, x minus 5 raised to 1/4. Again, since they have the same denominator here, therefore, they also have the same index. And then, this one is negative exponent. Negative exponent means reciprocal. X plus 5 will remain above. And then, you're going to put the x minus 5 beside x plus 5 because that is reciprocal of x minus 5. Then remove the negative 1 exponent here because you already write the x minus 5 into its reciprocal form. Now let's practice because I know that you already mastered how to write rational exponential form into radical form. First example, 2 raised to 3 halves. Now first you have to consider the denominator because that will be your index. Since that is 2, no need to write the 2 here because the symbol is already called square root. Square means 2. Then the exponent is our numerator. So the exponent here is 3 and the base is 2. Then 2 cubed means you're going to multiply 2 by itself 3 times. So 2 times 2 times 2, we get 8. But 8 is not yet in already simplified form. You have to get the factor of 8, which is 2 times 4. And did you remember the square root of 4? The square root of 4 is 2. And the 2 here will remain inside because 2 is not a perfect square. So the final answer here is 2 square root of 2. Another example, 2x raised to 4/3. Okay, our index here is 3. Next, our base is 2x and the exponent is 4. Then distribute the 4 into 2 and x. So we have 2 to the 4th power, x to the 4th power. Next, expand 2 times 2 times 2. then x times x because this is in the fourth power. So we get here 2 cubed. As you can notice, I get the exponent which is the same with our index because we can put it outside a radical symbol if we have the same index as the exponent of our radicand. And also we have here x times x, that is x cubed. Then we can put that out of the radical symbol. So 2 cubed divided by 3. 3 divide 3, that is 1. So we can put out this 2. Then x cubed, 3 divided by 3. We have here 1. So we can write it out, the x here. Then 2 and x remains inside the radical symbol. So the final answer here is 2x, cube root of 2x. Next, 2x raised to 5 halves. Now, the 2 here is the index here, and 2 is imaginary. And we have 2x to the 5th power, and 5 is the exponent of 2x. Can distribute 5. So we have here 2 to the 5th power, and x to the 5th power. Okay, since our answer here in radicand is greater than the index, 5 is greater than 2 and 5 is greater than 2. Therefore, this is not yet in final answer. So, we have to factor out the number which is divisible by 2. That is 2 to the 4th power times 2. 1 plus 4, that is 5. The factor of x to the 5th is x to the 4th power times x. Then 2 to the 4th can be divided, the exponent 4 can be divided into the index 2. So we get 2 square because 4 divided by 2 is 2. Then write it out, the 2 here. Next, x to the 4th, just do the same. The exponent 4 divided by the index 2. So we get 2. Then write down the exponent, or the variable x rather. Then the 2 and x will remain inside because their exponent is less than the index, which is 2. So extend or expand the 2 square here. The 2 square is equivalent to 4. Then copy x square. Then square root of 2x. This is now our final answer. Another example. So we have here 4xy raised to 3/7. 7 is the index, so we have here 7th power. A 7th root of 4xy is the base. Then cube is our exponent. Then distribute the exponent 3. So distribute 3 into 4, x and y. So we have here 4 cubed, that is 4 times 4 times 4. And copy x cubed and y cubed. So we get 64. Since 64 doesn't reach the exponent 7, if you're going to factor this number using the number 2, we just can get 5 or 6 2's, which doesn't meet 7. Then x cubed, then y cubed, their exponent are both less than 7. So this is already in final answer. Another example. I know that you are already familiar with this example. This negative exponent. So since this is negative exponent, the reciprocal of this one is you're going to put it above the fraction bar or beside the 5 minus y. So it is written in this form. Then the 2 here is the index, which is 2 or square root here. Now the final answer here is quantity of 5 minus y times the quantity of 5 plus y. So you have to remember this transition from the rational exponential form into radical form. The base is written as the radicand, the denominator is written as index, and the numerator is written as the exponent of the radicand, or these are their names. Okay, just remember this transition. And we have here notes. We need to impose the condition that a must be greater than 0 in the definition of nth root of a to the m power for an even number and because not hold true if a is less than 0. Now, if a is negative real number and n is positive integer, then a has no real nth root. And how? Remember that the index here is even number. Alright? If you're going to multiply any number to get 8, can you arrive into negative number? No, because if you multiply even numbers, or even if you count into even numbers those product or factor of our radicand, we cannot get a positive or real solution. As long as if the radicand is even and or the index is even and the radicand is negative, therefore there is no real root. Another. But if our index is odd numbers such as 3, 5, 7, 9, and so on, and our radicand is negative number, we can get a real root, which is negative 2. How? Because negative 2 times negative 2 times negative 2, we can get negative 8. Alright? Because we have here an exponent which is 3. But in negative 8 here, we cannot get negative 8 using the 2 exponent or power of 2. Because if you multiply two numbers, you always get positive number if they have the same sign. Therefore, there is no real root in even index and negative radicand. If a is a negative real number and n is positive integer, then a has no real nth root. So another example, again, this is even number for index and negative radicand, there is no real root. Another, we have here odd number index and we have negative radicand. The root here is negative 2. Remember the difference of these two. Since 5 is odd number, so we get the root which is negative 2. Thank you for listening. And remember, mistakes are proof that you are trying. Thank you for listening again and goodbye.